integration involving inverse trig functions. So we're not actually going to integrate the inverse trig functions themselves. That's not in the scope of the Extension 1 course. We will see how to do it in Extension 2, mind you. What we're dealing with basically is the going backwards of the differentiation. So if I see an integral like this, where it's in the form the square root of a squared minus x squared in the denominator, I know that it's come from the inverse sine function. And in that case, remember that was that linear one, x on a. Of course, we now have two possibilities. Because I could say it's minus the inverse cos of x on a. Remember, they were basically the same derivative. One was positive, one was negative. Which one do you use? It really depends on the question and what you're using it for. And we'll see that when we look at simple harmonic motion. In some cases it's better to take inverse sine, in some cases it's better to take inverse cos. We try and match the motion. The other one then would be the inverse tan one, dx on a squared plus x squared, so it comes 2. But notice, there's no a on the top here. In the derivative, a was on the top, so therefore when we integrate we get 1 on a out the front, so inverse tan of x on a. So we get one like that. Well, it's in the standard form already, so we know that in this case a is 2, so we get inverse sine x on 2, or if you prefer, minus the inverse cos of x on 2. Again in the standard form, this one's inverse tan, but I need to remember to put 1 on a out the front, so in this case 1/3 inverse tan x on 3. Definite integral. So a, be careful with this, because a is not 2. Remember, a squared is 2. So it's root 2 would be our a in this case. So inverse sine of x on root 2, and you're going to see these sorts of numbers crop up because the exact values it creates. Because when you sub in 1, you get inverse sine of 1 on root 2 minus inverse sine of 0. 1 on root 2, that's pi on 4, minus 0, so we get pi on 4. Ooh, here's a more interesting one. They give us a bit of a clue with this one. If I didn't know how to integrate e to the x on the square root of 1 minus e to the 2x, I would gamble and say that the answer is the inverse sine of e to the power of x. Because why on earth did they just ask me to do this? It could be some multiple of it, of course. Let's see what happens. It really feels like I'm doing nothing here, because I'm going to just go derivative over the square root of 1 minus the function squared. Oh look! That just happens to be what's in the integral sign. So, I mean, it looks like I've done nothing, but I mean, what else can I do? I mean, that's how I differentiate it. And so therefore, oh look, when I integrate it, I get the inverse sine of e to the x. Alright, sub in 0, so e to the power of 0 is of course 1. The other one's more interesting though, e to the minus log 2. Remember, the e and the log will cancel, but I need to have just log, not minus log. So I bring the minus in, so it becomes 2 to the minus 1, which is of course a half. So then the e to the log cancels and we just get a half. So be careful with your cancelling your e logs there. Remember, it has to just be log, not minus log, not 3 log, not, it's got to be log for it to cancel. Well, let's work those ones out. Inverse sine of 1, yes, that's pi on 2, and a half is pi on 6. We get pi on 3 as our answer. That one's more interesting, because it doesn't fit into the standard form, because our standard form is a squared minus x squared. So I'll make it fit, because I just want x squared, basically. So I'll factorise out the square root of 9. Square root of 9 is of course 3, and that means that a squared is now 4 on 9. So if a squared is 4 on 9, a is 2 on 3. Very good. Okay. I've just factorised the third out the front of the integral there. And so now we can say inverse sine of x on a, invert and multiply, and we get 3x on 2. Now the interesting thing there is, if you have a look at the question, we would have gone on a anyway, because of the 4, so it's on 2. But look what's happened with the 9x squared. Oh, it became 3x. So I could just do the square root, but of course I've got to be careful. If it's not x squared, I get the third out the front. I mean, if you can remember that, bang, all right, you get it in one hit. If you don't, well, then obviously we just do it that way. We'll factorise it out and you'll get the final answer. Ta-da! 1E.